Yes, neutrals can be shared for receptacles on a 120/208 volt three-phase system. The 2020 National Electrical Code, also known as the NEC, permits the use of a shared neutral conductor in specific situations. It's important to understand the relevant code sections to ensure safe and compliant electrical installations. Section 310.15 B3 of the NEC addresses neutral conductors. It generally states that neutral conductors should not be used to carry unbalanced loads unless specifically permitted elsewhere in the code. However, there are exceptions to this rule. Exception number 2 to section 310.15 B3 allows unbalanced loads to be supplied from a 3-wire, single-phase feeder or from one phase of a 3-phase, 4-wire feeder. This is permitted where the feeder has a neutral conductor and the maximum unbalance is within the limit specified in Article 220 of the NEC. Article 220 is crucial for understanding the allowable unbalanced load. Article 220 covers branch circuits and provides guidelines for calculating branch circuit, feeder, and service loads. Section 220.40 specifically addresses situations where only a single phase of a 3-phase, 4-wire system is used to supply a branch circuit. In such cases, an uninsulated neutral conductor must be run with the circuit conductors. The neutral conductor must be identified by a white or natural grey color, or by marking the conductor with the word neutral. This identification is essential for safety and proper wiring. To summarize the key points, firstly, the NEC generally prohibits neutral conductors from carrying unbalanced loads. Secondly, exception number 2 of section 310.15 B3 allows unbalanced loads to be supplied from one phase of a 3-phase, 4-wire feeder if certain conditions are met. Thirdly, Article 220 provides the requirements and limitations for unbalanced loads. Fourthly, Section 220.40 specifies the requirements for neutral conductors in single-phase branch circuits supplied from a 3-phase system. To further elaborate on Article 220, it's essential to understand how to calculate the unbalanced load. The unbalanced load is the difference between the loads connected to each phase of the 3-phase system. For example, if one phase has a load of 10 amps and another phase has a load of 5 amps, the unbalanced load is 5 amps. The NEC provides methods for calculating these loads, ensuring that the neutral conductor is sized appropriately to handle the potential unbalanced current. Correctly sizing the neutral conductor is critical for preventing overheating and potential fire hazards. The NEC includes tables and formulas to determine the appropriate conductor size based on calculated load and other factors, such as the insulation type and the ambient temperature. In addition to calculating the unbalanced load, it's also important to consider the harmonic content of the load. Nonlinear loads, such as electronic devices and LED lighting, can generate harmonic currents that flow in the neutral conductor. These harmonic currents can increase the neutral conductor's current carrying requirements, potentially exceeding its capacity if not properly accounted for. The NEC addresses harmonic currents and provides guidance on how to mitigate their effects, such as using oversized neutral conductors or harmonic filters. When sharing neutral conductors, it's important to ensure that each branch circuit is properly protected by a circuit breaker or fuse. This protection is essential for preventing overloads and short circuits, which could damage the wiring and create a fire hazard. The NEC specifies the overcurrent protection requirements for branch circuits based on the conductor size and the type of load being served. In addition to the code requirements, there are also best practices to consider when sharing neutral conductors. It is generally recommended to use separate neutral conductors for sensitive electronic equipment, such as computers and audio equipment. This helps to minimize the risk of electrical noise and interference, which can degrade the performance of these devices. It's also important to ensure that all electrical connections are properly made and tightened. Loose connections can create resistance, which can lead to overheating and potential fire hazards. Regular inspections and maintenance are essential for identifying and correcting any potential problems. When working with electrical systems, it's always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing circuits before working on them. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. They have the knowledge and experience to ensure that the electrical system is installed and maintained safely and in compliance with the NEC. To further clarify the requirements of Section 310.15, it's important to note that the exception allowing unbalanced loads is not a blanket permission. It is contingent upon meeting the requirements of Article 220. This means that the maximum unbalance must be within the limits specified in Article 220, and the neutral conductor must be properly sized to carry the unbalanced current. Furthermore, the exception applies only to 3-wire, single-phase feeders or one phase of a 3-phase, 4-wire feeder. It does not apply to other types of feeders or circuits. Another important consideration is the voltage drop in the neutral conductor. Voltage drop occurs when the voltage of the load is less than the voltage of the source due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction and can also increase energy consumption. The NEC recommends limiting the voltage drop in branch circuits and feeders to a maximum of 3% for power, heating, and lighting loads, and 5% for feeders only. When sharing neutral conductors, it's important to consider the potential for increased voltage drop due to the unbalanced current. The neutral conductor should be sized appropriately to minimize voltage drop and ensure that the equipment receives the proper voltage. In addition to voltage drop, it's also important to consider the impedance of the neutral conductor. Impedance is the total opposition to current flow in an alternating current circuit. It includes resistance, inductance, and capacitance. High impedance in the neutral conductor can cause voltage imbalances and can also increase the risk of electrical noise and interference. The NEC does not specify a maximum impedance for neutral conductors, but it's generally recommended to keep the impedance as low as possible. This can be achieved by using short, direct wiring runs and by avoiding sharp bends in the conductor. When sharing neutral conductors, it's also important to consider the potential for circulating currents. Circulating currents are unwanted currents that flow in the neutral conductor due to imbalances in the voltage or impedance of the different phases. These currents can increase the neutral conductor's current carrying requirements and can also cause overheating and potential fire hazards. The NEC does not specifically address circulating currents, but it's generally recommended to minimize them by balancing the loads on each phase and by using symmetrical wiring configurations. Furthermore, when working with 3-phase systems, it's crucial to understand the phase relationships between the different phases. In a balanced 3-phase system, the voltages on each phase are equal in magnitude and are displaced by 120 electrical degrees. However, in an unbalanced system, the voltages on each phase can be different in magnitude and can also be displaced by angles other than 120 degrees. These voltage imbalances can cause a variety of problems, including equipment malfunction, increased energy consumption, and harmonic currents. The NEC does not specifically address voltage imbalances, but it's generally recommended to keep the voltage imbalance as low as possible. This can be achieved by balancing the loads on each phase and by using voltage regulators or other power conditioning equipment. Moreover, the NEC requires that all electrical equipment be listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, also known as UL. This listing ensures that the equipment has been tested and meets certain safety standards. When selecting electrical equipment for a 3-phase system, it's important to choose equipment that is rated for the appropriate voltage and current. It's also important to ensure that the equipment is compatible with the other components of the system. In addition to the NEC requirements, there may also be local codes and regulations that apply to electrical installations. It's important to check with the local authorities to ensure that the installation complies with all applicable codes and regulations. Finally, it's important to remember that electrical work can be dangerous. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. They have the knowledge and experience to ensure that the electrical system is installed and maintained safely and in compliance with all applicable codes and regulations. They can help calculate load requirements, determine appropriate wire sizes, install all electrical equipment according to code, and ensure the safety of everyone who uses the electrical system. The electrician can also help identify and correct any potential problems before they become serious. Regular electrical inspections can also help identify potential problems and ensure that the electrical system is operating safely and efficiently. These inspections can also help prevent electrical fires and other hazards. When hiring an electrician, it's important to choose a qualified and licensed professional. You can check their credentials with the local licensing board and ask for references from previous clients. A qualified electrician will have the knowledge and experience to perform the work safely and in compliance with all applicable codes and regulations. In addition, they will be able to provide you with a written estimate of the cost of the work and a guarantee of their workmanship. Ensuring that an electrical system is properly installed and maintained is essential for the safety of everyone who uses it. By following the NEC and other applicable codes and regulations, and by hiring a qualified electrician, you can help ensure that the electrical system is safe, efficient, and reliable. Keep in mind that electrical codes are constantly being updated to reflect new technologies and safety concerns. It's important to stay informed about the latest changes to the NEC and other applicable codes and regulations. This information can be found on the National Fire Protection Association, also known as NFPA, website and from other sources. Staying informed about the latest electrical codes and regulations will help ensure that your electrical system is always up to date and in compliance with the latest safety standards. This will help protect you, your family, and your property from electrical hazards. By understanding these code provisions, it is clear that neutrals can be shared for receptacles on a 120/208 volt three-phase system, provided that the imbalance is within the limits of Article 220 and all other applicable requirements are met.